Vision, we have already covered a part of that use cases and all of that, right? So CNN, RNN. Okay, so some of the algorithms that are used for image classification, right? So the main thing is, like MNIST classification data set. If you are starting with computer vision problem, right, you need to start with your MNIST data set. You know the data set? Yeah, numbers are there, right? So you will have numbers from 1, 2, 3, I mean 0, 1, 2, 3. Handwritten character codes are there. We need to identify what is that number. Okay, using the CNN. Okay, that is the first one I have given. I have sent you. Hope you have received, right? Just I will talk for some of the use cases that are used for computer vision in the industry, and then we can get started with our case studies. Okay. Okay, so image classification, right? In our industry, some of the use cases that we were using is in one very recent project that we have done is on shop, no shop classification. That means there is an outlet. There is an outlet out there, and there are some field representatives who are actually. There is a use case where they need to actually audit. Okay, so what they are doing as part of the audit is like they are uploading images, geotagged images of the shops, and they are putting sending to the agents. Okay, so what the field representatives are putting the geotagged images of the shops. The agents who are sitting in the office are supposed to look at the images, check the geotag, identify whether it's really a shop or not, and then they have to do some approvals. There is a lot of process that is happening, but we need to identify whether the given uploaded image with the geotag is a shop or not a shop. So that is one of the requirements. So what we have done is we have built an image classification model, actually using CNN and all that. We tried different models, but I think CNN was giving good result. Okay, so basically what we are doing is we are trying to identify whether an uploaded image is a shop or not a shop. Okay, so the other requirement is that even the geotag, right, when the image is geotagged, we are actually pulling the lat-long values also from that. Latitude and longitude also from the geotag. There is one application that we did. The other one is in this real-time scenario, right, there are these real and fake images, right? Like we are not able, the AI generated images, they are all now fake. So they are putting so many images where they are showing that celebrities are going to Prayagraj, they are having a dip in the holy waters and they are coming, right? So it's all fake. There are so many AI generated images which are kind of fake. Okay, now the challenge, one of the major challenges is like how do you differentiate between real and fake images? You can take this as a project and solve. Okay, we are doing a research and we are building, we already built a model for that, which is around almost 99% accurately it is able to tell whether an image is a fake or real. Okay, so that is one other project. The other one is in the agri-technology, in agriculture, right? Okay, so I am talking about satellite images. Okay, anyone doing any project in agri-tech based on not only in agri-tech but based on satellite images? Anyone doing any projects on satellite images? Oh, super. Okay, what is the use case?
Building detection.
Building detection from satellite images. Oh, very good, very good. That is also good one. Yeah. So, in agri-technology, there are so many use cases are there. I'll tell you like few that you can explore. The data is available publicly in the internet. Okay. European Space Agency, ESA. Okay. So there are, if you go to this particular thing, right? If you type ESA, almost the entire globe is covered. The entire globe is actually from the satellite, right? The entire globe is covered, all different places, and the satellite images are available in ESA. There are like Sentinel-1, Sentinel-2. So some of those images are already available. Okay, so some of the use cases how it is like there are two different kinds of data with the original source like radar source or the sun as the source, right? So two different images will be there. One is optical images, the other is radar images. Optical means with a light source as with a separate light source other than sun, right? And then we have also sun as our light source. Okay, so when the images are captured from the satellite, what are all the things that we can do? Okay, what they are doing basically is, first of all, we need to identify whether the satellite, from the satellite image, we will first do an LULC classification. We will be first doing a LULC classification. Yes, ma'am. Yeah, sure. No, anyway, I'm just talking about some of the use cases. Ma'am, I have given the case studies, the notebooks. You can execute and let me know in case of any questions. Ma'am, I'm telling like in the industry, as I am working in the industry and some of the use cases that we are working on. Okay, so I'm not able to show you the board once again. Yeah, 1 second. Let me see if I can remove the background and but still it is not visible at this moment. That's okay, I will talk from here now. Sure, no problem, I talk here. So I'm just talking about some of the industry use cases that can be used. So I was telling that one of the industry use cases is a shop, no shop classification where the field staff are uploading the images of a shop, and then the agents are supposed to look at it, the geotagged images, and the agents are supposed to look at it and identify whether it's a shop or not a shop, based on the geolocation as well as on the picture. So we have built use cases around that, and we were doing image classification. If it is a shop image, we are capturing the geolocation also. From that image, we are able to extract the lat-long details. That is one of the use cases. The other one is identifying the fake and fake data from the AI-generated images. So in this one, what happens is usually it's an imbalance of data, because fake images will be too many and real images will be very less. So it's an imbalanced data set, and this is a very good problem that you can take up as one of your research, and then you can identify whether the images are real or fake. You can apply different image classification algorithms, but only thing is you might have a challenge with regards to balancing your data. That is one other problem. The third one that I am talking about is like one of the use cases that we are currently working on is on the agricultural use cases. Here, the main idea is like based on the satellite images. The satellite images are available in the internet, in the ESA, European Space Agency website, the Sentinel-1 and 2. Like this is one example. There are many other satellite images that are available. So what is some of the use cases that are as part of this is that from the satellite images we are supposed to identify whether it is a LULC or not, LULC use case, that means land use, land cover. Whether it's a land or not a land. If it's a land, what type of land it is? Is it an urban land? Is it a mountain terrain? Is it a water body? Is it a agricultural land, and so on? So first, from the satellite image, it will basically do some kind of a multi-class classification, and it will arrive around some 7 to 8 different kinds of classifications, whether it's a land, mountainous region, water, river body, urban, rural, or it's a agricultural land. Once you are identifying that it is an agricultural land, there is another set of classification on the same image that is performed, one of the use case where you will identify what is the type of crop that is growing. What is the type of crop that is growing on that particular land? Is it cotton, maize, wheat, paddy, and so on? Okay, there are around 0 to 255 different crops that can be identified. So we'll give one value for each one. It's a multi-class classification. So once you identify that it's an agricultural land, now based on that satellite image, we can actually tell whether it's a potato, maize, wheat, barley, mustard, and so on. What type of crop it is growing. There is another kind of algorithm. Okay, this also you can try to look at that also as one of your use cases. Okay, so once you identify that what type of crop it is, right? These two are like kind of image classifications, LULC as well as identifying the type of crop. Now once that is done, once you identify that what is the type of crop, now the next challenge is you can identify the yield of it. What is the yield in that particular region? So how do you calculate yield? It will become a regression model. It will no more be a classification model, it will become a regression model. So not only based on the image, you will need other field relevant information also. The ground information also, like what is the temperature, what is the weather, what is the weather parameters that you are having, what are the pressures, sensor data from the soil, so soil data, the farmer data. Basically, the farmers are all uploading their fields. They are digitizing their farms and they are giving information on their own information, like farmer ID, what type of crop they are growing, what is the yield of that, so what are the diseases they are getting from that. So that kind of field information is available. And also that particular geotag and location is there. Lat long values are there. And then we are also having that particular geotag location, temperature data is there. Okay, temperature, wind speed, humidity, that particular soil moisture information we are having. So from all of these things we can predict the yield of the crop. So once we predict the yield, right, this particular thing can be given as an agricultural worthiness score of that particular field for that particular farmer. There can also be many advisories that can be run for the farmer saying that, okay, if this is what is the prediction for the next 5 days, if there are going to be rains, what are you supposed to do? Okay, that kind of predictions can be done. Okay, they can tell ahead, proactively, they can intimate the farmers what can be done and what cannot be done. Okay, and also if the farmer is uploading any pest infestation that is happening in that particular field, right, that can also be looked into, analyzed based on the images. Again, image-based classification, disease identification can be done. So many use cases are there. So once they are able to do all of this, right, yield also is there. These particular things will be useful for the finance companies in providing insurance to the farmers. Any banks, right, they wanted to provide insurance for the farmers, right? So they can also look at the agricultural worthiness of the particular thing and they can do. And the other thing is that all of this that I am telling you now can be run at scale when we are using any of the cloud-based resources, AWS, Azure and all, right? Then that also can be done. The main challenge that we are seeing in terms of any of these models is, so the difference that we find with regards to academics and a research project compared to what we are expecting in the industry is mainly with regards to the deployment and the aftermath that happens after the deployment. Okay, people are able to build the model, but the problem that is happening is that there is no way that they are going to, whatever model they have built, they are deploying and they are taking the feedback. What happens after the deployment of the model is a question mark here with industry. When you deploy the model and it is used in production by the stakeholders, by the end users, okay, at one point of time there may be a deviation in the amount of the accuracy that we initially promised, right? Because of data drift, it can happen because of data drift, it can happen because of code drift, okay, and there is no feedback mechanism also that we are getting. There is no feedback mechanism back into the loop. Okay, so suppose for example I am building one application for farmers in the industry, right? The farmers are uploading the images of the pest infestation that is happening in their crop. So what I did is like I did an image-based classification in which I identify what is the type of disease. So I am telling them some kind of recommendation. And I am saying, okay, I identify what is the disease. And I give a recommendation saying, okay, if this is a disease, these are the pesticides or fertilizers that you need to do. This should be your soil moisture. This should be your amount of rainfall or the amount of water content that you need to do. The nitrogen content, the chlorophyll content. All of this I am able to tell them based on the satellite images. And the temperature is like this, the rainfall is like this. Correct? So now I am providing live updates for the farmers. But there should be a mechanism where I am capturing their feedback also. Okay, in the application that you are building. Whenever you are building an app, right, we should be able to have a mechanism where we capture back their feedback, saying that okay, it was helpful. No, it was not helpful. Whatever you told, the disease was not helpful. It is wrong because you know what? AI/ML algorithms are never guaranteeing you 100% accuracy. Correct? You are getting only around 70-80%. That too in this kind of a use cases, right? It may be around 75 to 80 or 85. So there may be a feedback or over a period of time because of the change of the training data and there is a shift in the training and testing data, right? The feedback that they are giving, right? It will be like, no, we are not able to. No, we are not able to. We are not able to get whatever. What you are saying is not correct. The disease that you are telling is not correct. It is something else. Okay, the disease that we identify is something else. So it is of no use. Or sometimes we are saying it is useful. So depending on the feedback that they are giving, if that feedback loop can be incorporated back, okay, into the model and you train again, okay, and whenever there are any changes that are happening, right? So those changes, if you are running in a CI/CD pipeline, continuous integration, continuous deployment kind of a pipeline, and if you are able to run this entire thing at scale, which means that if you want to not only for a small area, if you want to run for an entire state of India, you have to go with Amazon or any other cloud-based batch processing services. You can deploy them in a batch and run at one particular point of time, so that they pick all the inputs, they give you the results and they keep it back. So this entire process that is there, right? This is what is required in a real-time project. That is where it is missing. So any questions here? Yeah, the feedback mechanism is very important. Also, one other thing that we can do in terms of computer vision is the transfer learning. Okay, transfer learning, which is like you may train on one particular type of data or one region and build a model, but when you deploy, you are deploying in another region. Okay, so it will not be in the same region. That is called as transfer learning. Okay, so the training data or the region on which you are doing all of this, right, is different from the region in which you are deploying. It's called coming under transfer learning. So you will have to keep all of these things in view whenever you are trying to build your application. Okay, let me share my screen. Before that, let me look at one of the. So anyone here has done any project in computer vision till now? Anyone? Have you done something on any projects that you have done on Kaggle? Yes? See, I have shared you, I don't know if you are part of the group, I have shared you links. Can you please try to run these codes? If you should have an account with Kaggle. Yeah, I shared in that group, right? Yeah. Akila ma'am has shared the morning, like in the afternoon.
Ma'am, it's GCR, I guess.
GC.
GCR here.
Yes, ma'am. Okay. So if if you can open your laptops right here, I think you have the lab, right? If you can open. Can first one, you go to the first one.
Hands on that, ma'am.
Yes, ma'am.
System join कर लिया.
That's so we can.
System पे अपना देना. कोई नहीं है. System आपको. Work पर कैसे यार upload कर दो. और assignment
Yeah, please log into Kaggle using your account, personal accounts, and then you can run like how I am showing here, right? It is just like a Google Colab only.
display आ गया.
Right? It is like there are so many handwritten character codes which are written with hand, and we are supposed to identify with the help of image classification whether it's a 0, 1, 2, 3. So handwritten character codes. It is called as an MNIST. Just to get started, right? This will be the first project for anyone. So it is having so many training and testing images. We can get started on that. So I went into the Kaggle notebook. You have to just click on the copy and edit and then just run all. So here you can see the code, like what are libraries, what is it doing. So MNIST, like I told you, it's a data set which is used for like identifying whether that particular digit is what 0, 1 and so on. So there is in that we have given the path for the MNIST data set. Okay, based on the path, what are all the libraries? First, what are all the libraries that are used for downloading, right? It is using what? Matplotlib, TensorFlow, Keras. Okay, so the path it has given and then we are downloading that, correct? So these are like a written as a class and then there are function definitions. We are basically reading the images one by one, right? So the original MNIST data contains 128 by 128 binary images. Okay. So already we have seen that. First thing is what we have imported all the libraries. Second thing is what we are doing the data loading, MNIST data loading. Then they are doing the normalization and reshaping. The images are reshaped into 28 dimensions and one. It's not a 3 dimensions, it's only 1 dimension. 28 by 28 by 1. Then they are using convolutional neural network here. So how do you build a convolutional neural network? Keras.sequential. 32 filters, 3 by 3 kernel and radio activation function. If you see their layers, convolution 2D layer, max pooling layer and the flatten and dense layers. So here you can see how it is coming, right? 32 neurons are there, 3 by 3 is the kernel function, the activation function is ReLU. So in convolution neural network, basically you will have convolution layer, pooling layer. Okay, here we are using max pooling. We are doing converting to 2D, and then we are doing finally flattening and then dense. Finally, we are using softmax to get the output. So here the output will be how many? How many neurons will be there in the output function? 10 will be there. Because we need to identify 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? So the basic steps will be like Keras we are using. Keras.sequential. So this is how you build the convolution neural network. This entire thing is how you build. And in the 11th cell you can see how you compile the model. Model.compile, model.fit and model.evaluate. So display the sample MNIST images with the labels, right? So we are using the plot.imshow and plot.title for the display. Matplotlib we are using Matplotlib. So NumPy array is used for randomly taking that. See what are the labels? What is the difference between NumPy and pandas? What is the difference between NumPy and pandas? Okay. NumPy is for numerical Python. Pandas is like how you are reading your Excel files and crossing your data as a data frames. Okay. NumPy is used for your mathematical operations. It's a matrix or NumPy arrays. Okay, here you are using matplotlib for the display of the images, IM show, label, axis and all this, right? So import NumPy as NP. You are taking random dot choice. It's a function where you are taking 10 random indices from the training, 5 random indices from the testing. Sample images are being displayed here. Okay, with the help of the show function, sample images are displayed here. After that, what we are doing is like from PIL import image, file uploads, file handle inputs, and all that is written in the form of a function. So now we are doing the model.predict here. When you are given a new image, you are doing the prediction using the predict input. You input your image and then it is telling you upload any image and it will tell you whether it's a It is still running here in mine. Please run and see. You completed running entire one?
Yes, then I just reloaded.
It's running, right?
It's running successfully.
Can you try to upload one image and see? At the end, if it is running successfully. Down there, now you can upload because you already download Tell me if it is working. Mine is like still running. Finished that?
Yeah. Then we have to do segment by segment. Instead, we can download everything here. என்ன பண்ணணும் தெரியுமா? தம்பி எக்ஸ்பிளைன் பண்ணுமா? டவுன்லோட் பண்ணுமா?
இல்ல மேம் There are spots of I have created it and I have followed it. Right?
மேம் அந்த கேக் இல்லைன்னா டேரெக்டா ஓப்பன் in a notebook போட்டு கோலாப்லேயே ரன் பண்ணிடலாம்ல?
Yes, ma'am. Yes, ma'am. What did you
இல்லைன்னா you can directly run it.
Yes, ma'am. Yes, ma'am. Or we can copy and edit your option.
Copy and edit na மேல இருக்கு. And another version we have direct open.
Yeah. Yes, for collab also you can opt.
So execute this code in Colab, or you can directly execute this in Calendar itself. Got it, man? Correction last? Either you will copy.
So you can do any of these things, copy and edit, or if you click on the three dots, right, open in Collab, or you can download also. You can either run here or you can make in Collab also.
Execute by the GCL upload பண்ணோம் சரியா உங்களுக்கு attendance thank you ma'am. Cancel attendance students. Second year number 89. Number 116. Respect absent. 49. Bam present. Second year number 49. Bam present. 52. Present ma'am. 17. Present ma'am. 117. 117 absent. 103. 89. Number 6.
Present ma'am.
Now number 6.
Present ma'am.
Number 69. Nathan. 69. Not one. Absent 112 absent.
Present ma'am.
55. Absent 108.
Yes, ma'am.
21.
You need to upload the image and use the context.
Present 77, 53, 7 absent, 110, Aditya Balaji, 25, yeah, 79, okay, no circle. 88, 93, 96,
You can pass.
39.